All right, so we're going to spend the next, say, 20, 30 minutes looking at the data themselves. So we've spent the full day looking at how we can translate our data into the OMOP Common Data Model to make all of this possible, okay? So as we saw in the session after lunch, we can implement the strategist package and then upload the results, okay? And so with the fluoroquinolone study, we had 13 different databases do that exact process. So they ran their analysis package, generated the results, and then uploaded them into a database, and then that database, you can look through all of the results with a Shiny app. And you can access that Shiny app by going to this website. So if those of you who want to follow along, grab your laptops. I'm not seeing everybody rush into their laptops. Grab your laptops and at least, have a play along with me. So all you need to do is put in data.odyssey.org, and what that will do is bring up, and I'll do it as we... Okay, so if you put in just data.odyssey.org, we get this website. And if you haven't looked at this website before, you're missing out. There's a lot of stuff here that you can look at, not just fluoroquinolones, but a whole heap of stuff. If you want to go and have a look at the Legend results, they're there. I think Legend Basic Viewer, right? You can go into the Legend Basic Viewer. Let's hope this doesn't crash, and let's hope this works. Yep, there it is. So the Legend study that we were just talking about, all of the results are here for you to look at. They've been there for years for you to have a look at. So you can go in, you can, ask a specific question, the indication for the medicines, drugs, amlodipine versus, I don't know, Jody, help me out. Amlodipine versus carvedilol, whatever. Yep, acute myocardial infarction. That's exactly what you would have said. And here we are. Here are the results that we were just looking at. They're all here for you. So you can go and you can play with different, results that have been done through the OHDSI community. The UMAIS study is also here. The UMAIS study was looking at vaccine data and looking at operating characteristics of different methods for analysing vaccine safety. So all of that is there. Max SPRT, which I think somebody mentioned yesterday, maybe Patrick, some examples, of implementing that analytical approach. So, you can go and play to your heart's content with all of the great work that the OHDSI community have done and have actually uploaded those results. So that's all there. But the one we're interested in is this one here, the fluoroquinolone aortic aneurysm. So for those of you playing along, have a click on that one. And we get this analysis viewer. So just I'll orient you to the interface. So what we have here is basically like a pull-down menu for all the different things we can do. The About window is probably, when I started, one of my favorites, because what actually happens down here in the population level estimation prediction, you can click on any of these things, self-controlled case series, for example, and it gives you a really nice introduction to the package and to the method, and gives you some examples on how it runs. You can have a look at, way down the bottom here, installation instructions and some documentation as well. The package manual, you can have a look at vignette. We go in here, we open up a PDF, and it gives you some great information about actually what a self-controlled case series is. Okay, so some background information, how you install it, and then it goes through, all the different parts of the self-controlled case series, as well as some of the testing that the self-controlled case series package does. testing for seasonality in calendar time, considering event-dependent observation time. All of that is there. It's an absolute wealth of information for you to go and have a look at, to orient you to what we're actually doing and how you can interpret the diagnostics. So just wanted to give a shout out to that, because I think, there's so much work that has been done in the OHDSI community, pulling all of these things together and putting them in one source that you can go and have a look at. So makes it really easy for you. So let's go back to our viewer. I've got a couple open here. No. So, okay, so that's the About screen. And you can go and have a look at the cohort generator, for example, the different cohorts that were created and how many records are in each of those different cohorts. So we had an Atlas tutorial earlier today, and Chan was showing you that you could do that in Atlas as well, right? But you can also now do it in this Shiny app, having a look at how many subjects or how many records you've got in each of the different cohorts. And that would be the same in the Atlas interface as well. You can have a look at the cohort diagnostics, right, which is the thing we've just been talking about. Oh, sorry, that's objective data. This is cohort diagnostics. So you can look at the cohort definitions. Oh, I'm hoping it works. Yep, okay, so here's all the different cohorts. We can go to urinary tract infection, and here's the JSONs that we looked at prior, right, in the Atlas instance. We can look at cohort counts. We can look at the cohort definition. And this is the human readable cohort definition that we had in Atlas. Okay, so all of that information is here for you to look at in one spot. We can look at cohort counts, cohort characterizations. Let's pick one. Okay, so here's the for the JMDC database, looking at urinary tract infections. We can now see all the percentages in the different age groups of people who are in this cohort. So again, interacting with the cohorts and so on. Right, characterization, we can have a look at that. I'm not going to go into this too much, but let's have a generate the report. It's struggling. Not going to happen. Come on. Let's click out. Okay. So anyway, you can look into it. We won't do that right now. Estimation. This is now where we have all of the diagnostics that we've just been talking about for our cohort study. Okay. So we've implemented the cohort study in all our different databases, and here are all of the results for every single database, every single analytic that we ran. So the first page here, so we click on the estimation tab, we click on the diagnostics tab, and we see one line per analysis, one line per database, analysis window, what target, what comparator, and what outcome, okay? So this very first one here for the JMDC, it's a 30-day fixed window, the fluoroquinolone exposures with UTI compared to the cephalosporins, and looking at aortic aneurysm or dissection, okay? So then we can start to have a look at what were the results of all of our diagnostics and the summary result. So I'll go through each one individually. So the max standardized mean difference, okay, that's the maximum difference across all of the different covariates. We'll skip the shared max SMD for the minute. The equipoise, so what's the proportion of the preference scores that are within, the 0.3 and 0.7. Here it says 88%. The MDRR, the maximum detectable relative risk. The attrition fraction, so 60% left after we've done our propensity score matching. Our ease score, that we just heard Martijn tell us how we actually calculate that. And then we look through and see whether or not our diagnostics have passed. Okay, so we've got, yes, we passed on the balance diagnostics, we passed on the shared balance, passed on the equipoise, passed on the MDRR, attrition fraction, but then we failed on our E-score. Okay, so right up front, we're looking at all of our diagnostics for every single analysis that's been done. So I could just go up here, let's have a look, sort on our E-score, and I can go through and have a look at every single thing that passed, and there's up to 39 tabs, right? So there's a lot of information here. You can sort on, what else might we want to sort? On attrition fraction. Well, some of them are not there. E-score, not there if they're not calculated. But you see, you can just sort just the diagnostics at the start. So for each one of those, let's go back to JMDC. So here you've got little tabs up the top where you can actually filter for the different databases along the way. So we've got JMDC, and we can see that pretty much everything failed, okay? And right at the very end, we've got this unblind column. So the unblind column will be set to a value of 1 if all of our diagnostics pass. So it means everything has passed the diagnostic, so I'll now allow you to have a look at the result. It's unblinded, okay? If it's a 0, it means that at least one of those things has failed. If one thing fails, then you're out. There's no more looking, right? We will not unblind the result. So that's, a quick way of having an overview of whether or not for this particular database we've got any unblinded results. Okay. So we can now go to our results. And if we wait, okay, so we've got JMDC again. Now let's have a look at our 60-day risk window, okay? And we can have a look at, oh, don't do that. You have to be really careful not to click out. So you've got JMDC, we've got the 60-day fixed window, we've got fluoroquinolones, and I'm not going to look at trimethoprim because that doesn't. Let's look for cephalosporins. 60-day risk window, fluoroquinolones, cephalosporins, aortic aneurysm or aortic dissection. Yep, you can see that. So here we are, we've got a pass on our shared balance diagnostic, we've got a pass on our equipoise, we've got a pass on our MDRR, attrition, but we fail on our E. So this is the one we were looking at before. So we can, why is this not working? I'm still in diagnostic, sorry. My internet is struggling. I knew this was going to happen, so see what I created earlier? All right, let's just go through this. Okay, so we'll start with Optum. We've got the cohort generator. We can look at the cohorts. We went through that. So the study diagnostics, we've got all of our different criteria. We're going to go through each one of those. Now, the interesting thing about Strategis is that as Martijn mentioned, we do set our diagnostic criteria at the start. And so for the Strategis interface, the diagnostic criteria are set such that the equipoise has to be greater than 0.2, the covariate balance standardized mean difference has to be less than 0.1. There isn't a sort of a criteria for the generalizability, so it has to be at least less than 1, which will always be. And the E-score was less than 0.25. Okay, so keep that in mind. I'll keep that up the side. That's the cutoffs that we're using for these diagnostics in the Strategis framework. So if we look at the JMDC, the 60 days, fluoroquinolones, cephalosporins with our aortic aneurysm or aortic dissection outcome, okay? So that's just one of the results. And we saw that, everything passed for those except for the EASE diagnostic, okay? And it failed because it was 0.27. It was greater than 0.25. Okay, and so we click on, in the results section, we click on that particular result, and you can see that all of the results are NA, so they're not there because it didn't pass its diagnostic. Okay, so we don't see any results. But that doesn't mean we can't look at the diagnostics themselves and look at why they might have failed. Okay, so we can click on, different, the tabs there. So this here I'm clicking on the covariate balance tab, and it brings up for you the covariate graphs, the balance graphs that Jack showed you yesterday. Okay, so here on the x-axis is the covariate balance prior to propensity score adjustment. Okay, and if those of you that haven't seen these before, we're looking at the difference in the covariance, standardized mean difference before. So if it's 0.2, they're quite a way away, okay? 0.3, they're even further away. That makes sense? And then we plot that against the difference after propensity score. So here we've got lots of values that had big differences before the propensity score adjustment, and then we plot that after, and that difference has reduced right down to 0.05. Okay, so we've got big differences and then smaller differences after propensity score adjustment. And as Martijn said, there's a cutoff that we'll allow. In this case, it has to be less than 0.1. So any dot, all of our dots, have to be below 0.1 after propensity score adjustment. And you can see that that happens, okay? So it passed that diagnostic, okay? So the next tab is the propensity score tab, and we plot the propensity score or the preference score, which is a transformation of the propensity score. So what we want here is a good whack of our population being between 0.3 and 0.7, okay? And if I, get the area of the distribution between 0.3 and 0.7, I get 89%, okay? So 89% is less than our cutoff, okay? Equipoise has to be greater than 0.2, which it is, okay? So we've passed that diagnostic, yeah? Then we can look at power. So the tab here at the start, click on power, and we can start now to see how many subjects we're looking at. So we've got 10,000 subjects in our JMDC, and we've got minimal detectable relative risk of greater than 5, okay? So we don't actually have a cutoff for that as a diagnostic, okay? It's more of a kind of information. So we know that we're not really that well powered for this particular analysis. The JMDC database is quite a small data set, so we don't have a lot of subjects, and we've got very small numbers of events, okay? Then we can have a look at attrition, which is the next little tab along there. So we started off with nearly 25,000 in our target, 12,000 in our comparator, and then we end up, with 10,000 or so in each of the databases. So, we've lost quite a few from our target, but not so many from our comparator, okay? And again, we don't have like a cutoff diagnostic for that. That's about generalizability. Okay, and here's where it goes a little bit wrong. So we've got the EASE score, and the EASE score, is the summary of all of our negative control outcomes. And if I could put the little distribution that Martijn had up on his screen, you can see that, there's not that many negative control outcomes that we could run in the JMDC database, okay? Oh, I thought someone was asking a question. So we've got 9 estimates, and we've got, this distribution of outcomes of our negative control experiments. If we put a little, distribution here, we have an E-score that is far enough away from 0 that we fail this diagnostic, okay? 0.27 and 0.25, but it is greater than 0.25. That was our cutoff. We stick with that. It's 0.7, so this does not pass diagnostics, okay? So it fails, and because it's failed, we now don't look at that result, okay? Does that make sense to everybody so far? Yeah? Okay. So if we then look at the trimethoprim as the outcome, sorry, this one down the bottom here, you can't see it behind my screenshot. If I now look at trimethoprim, actually everything pretty much failed along the way, okay? So when we looked at cephalosporin, only one thing failed, the E's, but now pretty much everything fails. And if we look just at the power, we actually don't have any outcomes at all for this one, okay? So there's no point kind of going through and looking at anything else because we just don't have the data in this one. Okay, so that's JMDC. Any questions at this point? No? Is anyone following along? Doesn't look like it. Okay, so all right, let's have a look at Optum EHR. So Optum EHR is a really big data set. If I'm remembering correctly, I think that was 110 million people all up, okay? So it's a really big data set. And if we do the exact same thing that we did with the JMDC data set, and we go and have a look at our diagnostics, you can see pretty much that all of our diagnostics pass for this. If we compare the same risk window, the fluoroquinolones compared to cephalosporins, we get everything pass, and now we can unblind. Okay, so there's a 1 in our unblind column. And the same for the trimethoprim as well, we unblind. All right, so let's go through that. And because we're unblinded, we can now see the result. So when you're looking in the Shiny app, you go to the results section for all of those where unblind equals 1, and you'll see all of the results, okay? So here we've got Optum EHR, we've got the hazard ratio of 0.91, and the calibrated confidence intervals 0.73 to 1.09. Okay, so we're seeing the results. And we're very powered for this one, so 1.3 compared to what we had in the JMDC. Okay, so we've got quite a bit of power in this big database. If we look at our propensity score distribution, our preference score distributions, we get equipoise of 51%. Okay, we said we wanted equipoise to be greater than 0.2. Okay, so that passes its diagnostics. And if you remember back to yesterday as well, we had this kind of phenomenon in the US databases where our cephalosporin distributions were really sort of separated, and our trimethoprim distributions were very much overlapped. But even so, in the cephalosporin analysis, there was sufficient equipoise such that we could create our result or unblind our result. Okay, so I had to take a screenshot of this because my Shiny app died when I was making this. So, but this is what you get when you look at the website. Again, our propensity score distribution has really balanced our treatment groups. So we've got all of our standardized mean differences less than that magical 0.1 that we were talking about. So again, we pass diagnostics. Attrition, here we've got quite a lot that we lose, but we still have a very big number of patients that we have in this database. For our E-score, we get 0.04, okay? That's very tight. And you can see when you start looking at these, calibration plots, you can start to see how, the E-score kind of works from these distributions. And I've had a couple of chats with Martijn about this, and it's really a bit of an art to see how it works. But you can, it's very clear that we've got a very centralized distribution in our negative control outcomes, and that's kind of what the E-score is trying to, evaluate for you. So in this case, our ease is very, close to 1 and, close to 0, I should say, and we pass that diagnostic. Okay.
If you can go back to that one, Nicole. So I think one of the things that I get questioned about a lot is, so you're showing the uncalibrated estimates, and then you're showing the calibrated estimates. And in this case, it's almost hard to even discern the difference because calibration didn't do much. So I frequently get asked the question, like, why do we have to bother doing calibration? Because it didn't do much. But that's revisionist history. It's only because you see that it didn't do much that you know it didn't do much. There's oftentimes the case where if this was very biased, calibration would have to do a lot of correction, and then you'd want to see that. So I actually personally think about it as a very strong reassurance. When I see this plot match that plot, it means I didn't have to do a lot of correction. That's good news. It means our statistics worked. It's when you see lots of these dots that you can't even figure out which one do they correspond to, that probably means that there had to be a lot of correction that was done as part of the analysis.
Okay, any questions about that? I've got a few other things I want to show you, but, we could go through as many different examples as we want to of that. And, you can absolutely go through and do that yourself to really get a good understanding of what's going on. And one of the tips, for me at least, was to really just restrict yourself down to one analysis, keep everything constant, perhaps except for one thing, maybe the comparator, and then have a look at what's happening, or restrict yourself to one database and have a look at all the results for that database. But there's a lot of information there and a lot of results, and you can get quite overwhelmed. So this is one of the issues we have when we generate all this data, is really the digesting of it, and we talked about that a lot yesterday. So take your time, go through it, and sort of see the patterns. And once you start to see the patterns, it's really it's actually quite fun, I think anyway. So let's have a quick look if I'm back on our self-controlled case series. So as I think Patrick mentioned, all of our self-controlled case series results did not pass diagnostic, not a single one of them. Okay, so we did this work in our 13 different databases, and not one single result passed diagnostics. So we could have a look, so you can see, that no results are there. We just can't find one. Okay, they're all NA, but we can still have a look at our diagnostics. So pick an analysis. So let's just go through and remind ourselves. So it's the OPTIM-EHR. It's patients who have urinary tract, a 60-day window. Let me go back up here. And where am I seeing? Why can't I see the... I'm blanking where I see what treatment. Can you remember?
The exposure cohort there, it's just a number, unfortunately.
Oh, okay. Oh, fluoroquine. Okay. See, and there's a few bugs in the Shiny app viewer. So if you come across anything, which I just did then, let us know, because some of these things we can fix. And the group doing the back end have to deal with some of this as well, and look up the code numbers and attach the actual names to it. So there's some bugs that still need a bit of fixing. Okay, so the fluoroquinolones. So let's have a look at the results. So here we're looking at the time trend. So as Martine said, I think there are these underlying assumptions of the self-controlled case series. It was Patrick actually, and one of them is that there's this stable underlying time trend, and what you can see here is that it fails that. So this red says it's unstable time trend, and full disclosure, I've done a lot of self-controlled case series and published them in my time. And, sometimes I feel quite embarrassed that I've said, yes, we've adjusted for time trend by putting in time as a covariate in my model. And because I've said I've adjusted for time in my covariate model, then I've adjusted for time, thinking it's magic. But actually, there's never been a diagnostic necessarily that's as clear as this to say, well, you might have said you've adjusted for time trend, but actually, have you got rid of the time trend that's there? Okay, so just adjusting for something and saying you've done it doesn't actually guarantee that you've done it, and that's the power of these kinds of diagnostics. It's you can actually, unveil where you've gone wrong and fully disclose that, I did not always do this. So we've got the time trend that has failed. There is event-dependent observation. Wow, it's not going to work for me. It's coming. Okay, so another assumption of the self-control case series is that, your events are not dependent on, or the outcome does not, the events do not influence the exposure. It's not going to come up. It's okay. Time to event is another assumption. So what we're saying here is that we haven't got protopathic bias. So saying that, the group who are getting the outcome before exposure are not, greater, or the rate is not greater than after exposure. So if we compare the rate of the outcomes in the 30-day period prior to exposure and the 30-day period after exposure, you would expect that the pre-exposure is not higher than the after exposure. Otherwise, there would be, a failure of the assumption. And so this pre-exposure gain test helps us to understand whether we have a bias. So here it's saying that there is no difference, so it passes. Does it pass this test? Yes. So all of these tests can be done in the self-control case series, but none of them pass all diagnostics. So we have no results. So there's not really much to talk about in these. But again, it's really interesting to see the actual visualization of some of these assumptions that we kind of previously had just argued. So perhaps I can also show you, just for interest, that we have all of the prediction results in here as well. We have not had a chance to go through all these yet, since it's only been a couple of weeks. These results have been in here, but the next phase of our work is to really look through these prediction models and start to evaluate them, and all of the diagnostics are there as well for the prediction modelling. We have a meta-analysis tab here at the left, and here are all the meta-analysis results that we showed you yesterday. So, beautifully plotted here for us. So the cohort method plot, we've got aortic aneurysm or aortic dissection with fluoroquinolones, and we can see which one did we show? The 60-day plot here. So we had that. We're not seeing any significant increase in the outcome with either COMP1 and COMP2. So we've had a little issue about what COMP2 and COMP1 is. So there needs to be some labels here. But one is one is cephalosporins and the other trimethoprim. And I can't remember now which way it goes. COMP2 is trimethoprim. COMP1 is cephalosporin. Right. So our meta-analysis result is up the top there, and each of the individual databases that contributed to that meta-analysis result are here. And remember, I said yesterday, or Jack said yesterday at least, that we only include in the meta-analysis the results from which all of the diagnostics passed. Okay, so we haven't got the full spectrum of all of our databases here, because not all databases pass diagnostics. So only those that did contribute to the overall analysis in the meta-analysis. Okay.
Here's a good example there from the TMU data, as Stan presented earlier. They pass one and fail the other.
Yep.
That's why you see one estimate for them instead of two.
you see just here. Yep. And that must be cephalosporin, not trailing. Yep. Yep. So, any questions? That was a bit of a whirlwind tour through the Shiny app, but, you know, take your time, play with it. You know, one of the things I should have mentioned as well, that it's absolutely amazing, but you can go into your results if it does it. You can go into your results and, you know, play around with those diagnostics and, you know, the preference score distributions and so on. There's a little button there that says export as a, you know, PNG or a, you know, an actual formatted beautiful graph, right? So you can download all of these things and, you know, put them in your paper if you want, or you can have the fancy people in the other room, you know, attacking the back end of the strategist's database and actually creating, you know, graphs for you that way as well. So there's all of these, you know, functions that help you to write your papers and to really, you know, play with the data. So it's, you know, an amazing kind of tool to help us with our research, and I'm very grateful. Yeah.
I have something curious about covariate matching. When we match thousands of covariates, isn't it okay to just a few covariates of standardized mean differentiation is above 0.1? If the covariates above the 0.1 is when a doctor or some clinician review all of that covariates, and if they say that covariates is not relevant to the outcome, isn't it okay to just embrace the results of that database?
I'll answer. You make me smile because Martine and I have had lots of fights with lots of peoples about this. So the challenge, so the example you're bringing up is you balance on most variables, but there's a small handful, and then you post hoc rationalize why the couple that fail probably aren't a problem. And the challenge is, if you knew that they weren't a problem, you wouldn't have had to investigate them in the first place. And the whole thing is that confounding inherently is not knowable, or at least not deterministically knowable. So the idea that someone can post hoc determine that it's not a problem is exactly the kind of issue that we are trying to resolve with objective diagnostics, because one of two things could happen. You saw the answer you liked, so therefore you say, oh, that confounding is not really a problem. Or you see the answer you don't like and you say, oh, those small number of things is the reasons why I'll throw this study out. And instead, I think it's important that we have rules that we adhere to pre-specified. And what we've seen, we've had this happen actually numerous times. It's a little bit annoying when you get one variable out of 50,000 and it has a standardized mean difference of 0.11. And people will be like, come on, can't we like let it slide? And if your opinion is you should have let it slide, then my argument would be you should have pre-specified your real rule to be 0.15 instead of 0.1, because then it would have been an honest process that you could have followed. But after you see it and after you're playing with it, we would argue that that's not something that you should provide latitude towards.
Oh, thank you very much for your explanation. I think, yeah, that philosophy is really good to make a really firm, evidence. And I have another question about equipoise. And before a propensity score matching or propensity score certification, if target course and comparative course differs a lot and overlaps a really small portion, can we fix that problem with one-to-one propensity score matching? Because we are only investigating that overlapping patients, and all of the other non-overlapping patients are going away.
Yeah.
And doesn't it
That becomes more of a generalizability problem, and correct me if I'm wrong. It's much more of a generalizability problem because there is something that's going on in the healthcare that means that those two groups of people are getting the treatments for very different reasons. If the propensity score distributions are so far apart that you've only got a very small overlap in the middle, and you're wanting to do your analysis on that tiny group of people for which either treatment could potentially have been given, it just happened that they got one or the other, then I think you have a generalizability problem. But Martijn is coming up to
I think that's actually a very, very good question. And actually, I was of the same opinion until very recently. Like if we can achieve covariate balance and everything, then that probably means we can still get a valid estimate, although we're not sure how well it generalizes. But then we ran this experiment that I just showed you that actually said that if the equipoise is low, then even if you achieve balance, it seems that it's hard to get a reliable estimate. So that's why I've actually myself have gone back on that. So if equipoise is really low, it seems we just shouldn't do it, is what the current evidence is suggesting. But the current threshold of 0.2 is a very lenient one.
Yeah.
I think the point there also, just to reinforce, is the main message we want you to take away is pre-specify your rule. If you decided up front, I don't care about generalizability. Okay, you don't care about generalizability, do your study with one-to-one matching in that small group. You can expect a reviewer of your paper is going to wonder, why is it that only 3% of the people qualify for the study? But you could make that choice just as long as you pre-specified it. What we don't want you to do is post hoc rationalize. And what have grown to be very humble about is the data has a lot of knowledge that we can't possibly as humans know a priori. And so most of the time when I pick a target and a comparator, I expect them to be pretty comparable. I've picked them because they treat the same indication. I think they're in the same line of therapy. I expect them to be good. And so usually when I see that separation, it's because there's something that I didn't know about that's causing that to happen. And so oftentimes when I see that, it's an insight that I didn't have before that's causing that to happen. It's not that I was acceptable of that ahead of time.
Thank you very much.
I'll just add one more comment, so particularly with the irony of the bad gateway popping up there. One of the things about this application that I hope is clear, but I'll just try to reinforce it. This software that you're seeing, this web page that come up, that was not developed for the fluoroquinolone aortic aneurysm study. That is the exact same website that gets deployed for any study that you do. Now, the technical thing that Nicole's going through right now is literally because we have one shared OHDSI community server that has like some limit on the number of people that can touch it at the same time. So it's probably rebooting right now, which is what's causing that to happen. But you locally, when you run the strategist package, you now have that Shiny app locally, and then you can choose to deploy it to whatever Shiny server is in the world. You're welcome to deploy it to the OHDSI server, but you can deploy it to your own server, you can do it locally, you can do whatever you want. But the point is that you get this full-fledged, highly interactive website for every study you do following this package. And it's the exact same thing every single time. That's kind of the power of the standardized analytics. The lack of power of our OHDSI open source community server is demonstrating to be a problem, but you can run it on your own. Like this app, in fact, usually when like I run a study or somebody in my team runs a study, the very first thing we would do is we run the package and then we would have this running locally on our laptop. And actually Than showed that earlier, like you just have it running on your laptop. It doesn't take very much. It's actually just the deployment to some other web server so other people can see it. That's really what we're experiencing right now.
Questions? Yeah.
Sorry, this isn't actually about what you've just gone through, which I think has really been really helpful and really expanding. But for a newcomer to OHDSI, if you want to start a new project, new study, how do you know what other data sets are potentially available to approach people to say, are you interested in answering? Is there a library somewhere that you can say, okay, this country, this country, this country have got something that we might think at face value may be appropriate? So it's a really basic question.
Yeah. So, so well, so do you want to, if you go back to data.odyssey.org, you may be able to get to the data diagnostics. Hopefully that one will maybe open. I think the whole shiny server. No, it's coming up. Let's see.
Yep.
So while Nicole's pulling this, I'll just explain briefly. So there's two things that are available. So one is there's just a list of databases. So we've got 400 databases converted to the common data model. You can have the name of the database, the country, that kind of thing. But actually the thing that we've recognized, and within the community, there are various pockets, such as the Eden community, which is part of our European effort, where they have a catalog. You can get a free username and password, and you can log in, and you can basically browse, I think it's like 150 databases right now. So you can go see what they all have. But that first box of our 3-step process was data diagnostics. And the idea is you shouldn't ask for which databases you want for a study. Rather, you should specify your question, and the data should tell you which databases are eligible for your study. And so what Nicole has here is the data diagnostic tool. So there's like, I forget how many now, 35 databases that contributed summary statistics about themselves. And what we did was we actually said, here's the question was fluoroquinolone and aortic aneurysm. And we were able to see which databases have all the required data elements to pass. And so this was that first stage of our 3-step process. Our long-term vision was if we could get every database that's converted to the OMOP common data model to contribute this minimal set of statistics, then anybody could just pass in a question and run it. So yeah, that drop down there, let's see, there's fluoroquinolones, it's somewhere in there. So you can see here, you're now picked a different analysis, and now you're basically seeing all the databases and which ones actually satisfy which criteria. And so what this allows us to do is, for the 35 databases, we can see which ones pass and fail which criteria and what is the expected sample size for your study. Right now, it is much more of a social process. So if you've got a question, you can go out on the Odyssey forums and say, hey, I'd like to study drug X or whatever, intervention X and outcome Y. Is anybody interested? And you'll just get a whole bunch of people that'll just raise their hand and say, I'm interested. What we'd like for you to do is the next step would be to formalize that into an analysis specification and a protocol. And step 1 would be, let's run data diagnostics to see if that data actually has the elements you need to then move forward.
So you can, for this one here, Premier, I don't know what that one is. It fails on some sort of diagnostic, and that diagnostic was the proportion with longitudinal criteria. So I don't know that database, but it mustn't be longitudinal.
Yeah, so that's actually relevant for you guys. That's a hospital database. So the only information it has is the time while you're admitted from admission to discharge. It doesn't have information between hospitalizations. So that's like many of the state databases here. And so this study, we required that people have at least a year of continuous follow-up because that's what we needed for our fluoroquinolone study. So this one failed a diagnostic because it doesn't actually have lots of people that have a full year of follow-up because it's only people that are in the hospital for a day or so. So that's why we didn't bother to even consider running this study on that data set because we knew it was gonna not be acceptable.
And others here didn't have procedure criteria, so we needed procedures to see that the treatment of the aortic aneurysm or dissection was part of our cohort definition. So it doesn't have that element, therefore it doesn't pass and it hasn't contributed to the study. Catherine giving you 5 minutes.
5 minutes and then you're all can all escape.
Hang on, can I get a photo of that?
Yes.
Lovely. 5 minutes left of this Odyssey 2023 Symposium. Other questions? Anything you want to ask just in general about the day or yesterday? Anybody who hasn't been signed up to Odyssey that now would love to be signed up to Odyssey in some way? You're all in. Great. All right. Well, if there's nothing else, I think I'm going to close the session. Yay! Excellent. I just wanted to thank, again, all of the speakers for today. It's been a huge effort getting this tutorial together, and we've had some excellent speakers. We're really lucky to have these guys and women come to Australia and give us these presentations. So I'm really, really thankful for that. Thanks for the sound guy up the back. Yay! And just everybody who put this together. I won't name everybody, but thank you so much, everybody. And I hope we've shown you how great this journey is. So come with us, and OHDSI Australia is going to, do lots of events to sort of keep this momentum going forward. So keep an eye out. We'll be doing lots of stuff. So thanks, everybody.